cones and pyramids. Take one. Okay. So this is called a cone. Okay. This is called a right cone because both of these, because it's symmetric about this thing called the height. Okay, is perpendicular to the base and it's symmetric. An oblique cone. Let's see if I can draw an oblique cone. I think I can. Where's my tool that I'm looking for? This one. An oblique cone would look like something like, let's see if I could do this. I think I can. Let's make these lines solid. Solid. An oblique, stop drumming, okay? That would be a picture of an oblique cone, okay? And still you find the volume the same way as you find the volume of this cone. Only in this case, you would have to find the height. The height would be the distance from the vertex down to the bottom, okay? The perpendicular distance. So if I were finding the height of this one, I'd have to know how far it is from here to the ground. It's kind of like the Leaning Tower of Pisa. You know the Leaning Tower of Pisa? Right? Okay, Stephanie and Chad, I'm going to send this video to your mom to let her know that you're talking too much in class. Okay. So anyway, the volume formula, does anyone happen to know the formula for the volume of a cone? It 1/3, very good. It's very similar. Yeah, pi r squared times h. Okay, so in this case, this is the base. Okay, the area of the base. So the area of the base is this thing, which we know is pi r squared. But for a cone, there's methods geometrically of proving this and using calculus, which I've done before, of proving that this is true. But it turns out to be a cone is 1/3 the area of the base times the height. So if I were to take, for instance, a cylinder, let's see if I could do this. I'm getting too ahead of myself here. But if I were to take a cylinder, like similar to this thing, and then drop some lines, whoops, and then make this like this and like that, that's not exactly straight. But this cone would take up 1/3 of the volume of that cylinder, okay? So if I were to do that, that's what you could show geometrically that's true, or using calculus that that's true. Okay, so let's just find the volume of a simple cone. Oh, and the other thing in a cone, does anyone remember what this side is called? That's called the slant height, okay? And a lot of times they'll just give you the side of a cone, and they won't give you the, what? Yeah, well, then you'll have to, well, maybe 30, 60, 90, but usually they'll just give you one where you have to use a Pythagorean theorem. So maybe they'll tell you that the slant height over here is 5, okay? And that the radius is 3. And they'll say, find the volume. Find the volume. Well, so anyway, find the volume, okay? So I'm going to call this h, right? And so you need to know the height. You don't need to know this slant height. So the volume you're going to find, the height you're going to find by doing Pythagorean theorem. 3 squared plus h squared equals 5 squared. And then you know this is a Pythagorean triple. Does anyone remember what h is going to be? 4, right? So doing the Pythagorean theorem, you get h equals 5. I have 4. Sorry, h equals 4. And then I just plug into this formula. So the volume in this case is going to be 1/3 pi times 3 squared, right? 3 squared times h, which is 4. And then I try to simplify as much as I can. Okay, so this is going to be 9 divided by 3. What's 9 divided by 3? And what's 3 times 4? So the volume is going to be 12 pi. And if those are like centimeters, it would be cubic centimeter. Okay? So that's how you do the volume of a cone. They get a little more complicated than that, but I'll let you work on these. Okay? I'm just going to do one more example, and then we're going to be done. So almost done. Find the volume of the volume of the hexagonal pyramid. Okay, so I searched online and I found other pretty pictures, and I found this one. Where's my hexagonal pyramid? Let's see. This is cool because you can just steal things from the internet and put them on here. Okay, where'd my hexagonal pyramid go? There it is. Okay, so then I could just drag it over there, and there it is. Isn't that cool? Okay, technology. It's amazing. Okay, so the volume of a pyramid is just like the volume of a cone. It's almost exactly the same formula. It is exactly the same formula. It's 1/3 the area of the base. Whoops. The area of the base. Why did I make that little squiggly thing? The area of the base times the height. So again, this is the area of the base. It's not the length of anything. Okay? And so this is the height, again in a cone. This is called the slant height, and this is the radius over here. So say I know in this case that this is, so this one's going to be a little bit trickier. Say I know that this side is 8. And what else do I know? And I know that this height is 10. Okay? And they say, find the volume. That's all they give you. And they say, find the volume of the, that's called the hexagonal pyramid. Could you do that? Not so easily, I'm guessing. Yeah. So first you have to find the area of the base, which is a little bit tricky. And the way you do that is by making this into equilateral triangles. You see this over here? Remember this? There's an equilateral triangle that is an equilateral triangle right there, right? Because you have an irregular hexagon, which we're assuming that this is. So what does the radius have to be? 8. But that's not really what I need to know for a hexagonal pyramid, but I'm going to draw the radius over to here. That's not going to be the radius, is it? Okay, watch. This is tricky. Let's look over here. Okay. See that little triangle there? Yeah. I'm going to make it bigger. Okay. So I'm going to draw a picture of a triangle, or attempt to draw a picture of a triangle. Let's see. Oh, pretty good, huh? Okay. So this is going to be 8. This is going to be 8. This is going to be 8. And then I want to find the height of that triangle. So not all of your problems are going to be this hard. Okay, I'm just trying to give you one that's a little bit challenging. So if this is 8, who can tell me what that height has to be? 4 square root. Very good. 4 square root of 3. You guys are smart. Because this is a 60, because these are all equilateral triangles, so all these angles are 60, right? And that's 30. So this over here is going to be 4, right? Half of the hypotenuse, and then I multiply, or half of the hypotenuse, and this is a little right angle here, right? So that's 4, and I multiply by root 3. So the height of that is 4 root 3. So now I'm going to go, first I'm going to find the area of the base. So the base is going to be, do you remember this formula? Side squared root of 3 over 4. That's the area for an equilateral triangle. But how many of those equilateral triangles do I have? in a hexagon? 6, right? 1, 2, 3, 4, 5, 6. So I have 6 of those. So all I do to find the area of the base is I plug in 8 over here, right? Side squared root 3 over 4. So the area of the base is going to be 64 divided by 4. What's 64 divided by 4? 16 times 6. Hello? 96 root 3. Do you guys see where we got that from? Okay, so that's kind of tricky. Oh, they told me the height already, didn't they? So I don't really need anything else than that. But in some cases, I would need to do maybe they give me the slant height, right? And then I'd have to do the Pythagorean theorem to find the height over here. Like they might give me the slant height instead, okay? And then knowing the radius, you would have to do the Pythagorean theorem, this squared minus this squared to find the height. But in this case, you don't have to do that. So all I have to do is then multiply by 10 and then divide by 3, right? Because it's 1/3 the area of the base times the height. So divided by 3. Does 96 go into 3? I mean, does 3 go into 96?
Yeah.
Yes, it goes in 32 times, right?
Why do you say divided by 4 on the first one?
Because this is for this formula right here. That's the formula for the area of an equilateral triangle, okay, which I've given you several. Okay? No, for a regular triangle, this formula comes out of base times height divided by 2, and it ends up being this, okay? But, shh, stop, shush, okay? So when I simplify this, I get 32 times 10, right? 3 goes into 96, 32 times 10. So I get 320 times the square root of 3. And if those are inches, you would say that's inches cubed, or cubic inches. So if I called it all these inches, and that's inches, then that would be my answer right there. And it gets a little more complex in your homework, but that's about it. Look, we're done in 12 minutes. The end. Okay? Goodbye.